M5 Pro Macbook Pro. 18 cores in a CPU, what am I even supposed to do with this thing? The leap from the base model M5 MacBook Pro to the M5 Pro MacBook Pro is so big, I didn't initially know exactly how to test this thing out. Normally, programs don't use 18 CPU cores to do their thing. First, here's just a quick trip through the obscene benchmark speeds and really the purely outrageous power in this laptop. The SSD. The storage in here, double the speed of the base model. The SSD in here can read and write faster than DDR3 RAM from a decade ago. I suppose if you're not a hardware enthusiast, that may not hit as hard as it should. Mine's hitting 12 gigabytes with a big B per second, and that's actually even a bit slower than it's capable of. My drive is starting to fill up because of all the games I downloaded for crossover for testing, which we'll get to later in this video. In Cinebench, this year's M5 Pro actually scores ahead of last year's M4 Max, a computer that costs another $1,000 more than this one does, $8,200 to $7,800 for the multi-core CPU test. The base model M5 is way off, less than half the multi-core score at a little under 4,000. And this score will inform what will happen with massively parallelized processes and how they'll go in a minute. The M5 Pro MacBook Pro gets its brute strength from a very large number of parallel CPU and GPU cores. And it actually has nothing at all to do with the speed of those cores when you're comparing the same generation, M5 to M5. The super cores in my M5 base model are the same as the ones in the M5 Pro. In fact, my M5 base model beat my M5 Pro just by a little bit in the single core test. And that explains why, for a majority of uses between these two computers, they feel exactly the same. You will experience exactly zero additional performance when using an M5 Pro versus an M5 base model while doing almost anything that almost anyone ever does on a computer. It's not like before when the biggest, baddest Intel Macs had faster processors in them than the base models. Now they just have more cores. So if what you're doing uses 4 CPU cores or less, well, then this $700 upgrade will offer you nothing. You lose. Let me show you some things. M5 Pro has over double the score on Cinebench. But if we do something normal on both of these computers, like open a Photoshop file, blam, same speed. Let's load up the Billie Eilish song demo on Logic Pro. Kapow, tied. Even though this benchmarks at over twice as fast, the CPU, the GPU, and the SSD speed twice as fast. Opening a project into AutoCAD doesn't use all of those extra cores. And what it does use just can't drink in data fast enough from the SSD to take advantage of that either. This is true for editing photos, editing video, even if you're doing those things while listening to music or watching a video. Sure, you're technically multitasking, but that's using like 2 to 4 CPU cores, and you've already got 10 in the base model. Okay, fine, so programs open up and load at about the same speed. And a lot of programs will operate at about the same speed. Exporting is the thing where you really see the speed, right? Well, not always. Here's a 4K video project, 2 cameras, mild effects. This was a video I made on my other channel talking about how I light my studio. And when I put these two computers side by side, the base model M5 MacBook Pro and the M5 Pro MacBook Pro, and hit export, this actually surprised me quite a bit. But it turns out that a majority of what's happening on an export of this particular complexity is happening in the media engines, which are the same on these two computers. You'd have to bump up to the M5 Max to get an additional media engine, which drastically speeds up all exports. Some stuff happens on the GPU, and you can see the GPUs working a bit wherever I put the thing on here. They're handling the rendering of animated titles and whatever effects layers I had on this video. It's just that even the weak GPU can do all that work as fast as the media engine can crank out that H.264 file. So you don't get any additional speed by having more additional CPU and GPU cores. So all those extra processors and this robust GPU, just chilling. And these two computers did that export at about the same speed. The M5 Pro pulls ahead a little bit at the very end, but it's like 5 seconds faster. It's negligible. Turns out that not until you find things that use a large amount of parallelization can you really unlock the demons that live inside this M5 Pro. So those of you who want to justify this purchase just because you're starting a YouTube channel where you're using one 4K camera, I'm sorry, it really just won't do much extra for you unless you want to play video games. So let's find that speed and find a way to wake up those demons. 8K video is another story. It's just that hardly anybody's shooting 8K video. I tried a different project, and the GPU does get hammered enough when you're rendering out 8K footage that this computer finishes 3.5 minutes faster than this computer on a 12-minute long video. Now we're getting somewhere. If you use proxies, and I think you should, if for no other reason than as a RAM management strategy, editing with proxies uses quite a bit less RAM than editing with the files that come straight out of your camera. Even if your computer can handle it, it just handles it better. This would translate also to if you keep a huge Plex video library and have to transcode all those files. I tested the proxy creation process on a bigger project, on an 8K project, from my last video where I was talking about the MacBook Neo and whether it could edit. Making proxy files still doesn't hit all of the CPU cores, so you're not using everything in here, but it uses a lot more GPU. So this project has one fairly large, I think it's a 40-minute 8K clip, and then a 40-minute 4K clip, and then all the B-roll clips. So there's like 20 more clips that have to be translated before you can start editing, transcoded. That process took 15 minutes and 39 seconds on the base model M5, and the M5 Pro chewed through those same files in just 9 minutes and 11 seconds. So that's something like 60% faster. Very good. That was promising, so then I started looking for tasks that use more or all of the CPU cores at once. One thing I regularly test for thermal throttling on these laptops is a big Lightroom export. So here are both computers, both exporting 549 raw 33 megapixel images into JPEGs. And not only is the Pro able to do this about twice as fast, but it's doing it while it's more than 10 degrees Celsius cooler than the base model, because there's 2 fans in here instead of 1, and it's also pulling 50 watts instead of 30 watts throughout the process. The M5 Pro converted these 549 pictures in 55 seconds. The base model took 1 minute and 48 seconds. Where'd that Neo go? For reference, I had tested this same thing on the MacBook Neo, and this took 10 minutes and 33 seconds for the same test, aka 1 order of magnitude slower than the M5 Pro MacBook Pro. Running Windows in Parallels seems to work pretty fine on here, although admittedly I am so much of a Mac user that I really don't know what to do once I get into Windows to test stuff out. The same thing happens when I try to review Windows computers. Asus sent me this ZenBook Duo, this like dual screen monstrous laptop thing, a really big, like 2 screens of screen, keyboard that kind of attaches in front of it, and whatever. It's this crazy laptop with the Panther Lake processor. Very nice, has great specs. I just don't know what to do on Windows to test stuff. Woe is me. Anyway, using a virtual machine definitely uses more CPU cores to be doing the translation layer. I installed the Windows version of AutoCAD on here, because I know that's got some different features than the Mac version, so it's reasonable to expect someone might want to do that, someone might want to use that. And I will say, if I just put it in full screen, I would think this is running natively. It is perfectly responsive in Parallels, or at least AutoCAD is. This does run the ARM version of Windows when you're using Parallels, so you'll probably still run into some compatibility issues when you're working with x86 software. Far more exciting than Parallels though is Crossover, and holy crap, this is a lot better than I thought it would be on this computer. Here's Star Wars Outlaws on 1440p with the graphics set on high settings, and we're getting between 45 and 50 frames per second. And back to that multitasking, this is all while I've got a second screen up with a video playing and all my texts and emails coming through. In the past, I had been bringing an extra computer. I had brought this Victus gaming computer with me on these shows I travel to, just so I can feed my Anno 1800 addiction when I'm on a plane and when I'm on the road. But that's only because I didn't know about Crossover. I had heard about it, but I had never tried it on my M4 Max. I've been missing out for years. But now I can design my perfect little shipping routes on this computer until my heart's content, and there's not even a performance hit. So this thing is at least as good as a mobile 4050 GPU, not that that's super special in any way. I'm gonna have to add that to the list of things I test on weaker Mac computers, because this does have double the GPU from the base model. To me, that's a fine reason to upgrade. $700 for basically a Windows gaming computer to go. Because it has so many CPU and GPU cores, this computer can multitask hilariously well. I was installing Star Wars Outlaws through Crossover while I was installing the Windows version of AutoCAD through Parallels, so I'm already splitting the computer's attention across 2 virtualizations, Crossover and Parallels. I went ahead and started up Assassin's Creed Shadows, the Mac version, the native version, while this was happening. I ran a benchmark, and good lord, I was still hitting 50 to 60 frames per second on Assassin's Creed Shadows while installing 2 different softwares on 2 different virtual machines. So maybe installing just isn't demanding enough? So I went back and re-exported that same 4K video, and my god, there is enough headroom to get in there and kill some ninjas at 1440p at 50 frames per second while exporting a 4K Final Cut Pro project. Shoot me in the face. Next, it's time to show why I think Apple has gone to these lengths with the SSD speed and the RAM throughput, and that is because they are gearing up, mark my words, to release a Siri that is a large language model running locally on your Mac. In Ollama, I've got the 20B version of ChatGPT loaded up and ready to run locally, but you can look and see the RAM down here. It's not loaded yet. It's just ready to go. It doesn't actually load the model until you ask it the first question. You'll see that RAM jump from whatever it is to double whatever it is. So check this out. Tell me the fastest way to boil an egg, and bam, that model is like 13 gigabytes, and it can load up and answer answer that question in like 1 second. And that's without this being optimized and built into the OS. I think these machines are so fast and the SSDs are so fast because Apple's gonna make it so it can just whip up a local LLM to answer your Siri queries all super fast and then unload that so it doesn't hog the RAM long term. And I think they will make this announcement later this year. This prediction is based on nothing but a hunch. But anyway, the upgrades on this machine are seemingly purpose-built for local LLMs. The neural accelerators on the GPU seem to be custom designed for that. This is all if you get enough RAM with it, I guess. I went with 48 gigabytes of RAM because I am simply a lowly video editor, but I wanted to be able to be a little greedy and just have all of my programs open at once. Pages, Final Cut, Photoshop, Lightroom, Safari, Mail, Teams, Outlook, Chrome, all of that running at one time, and I've still got 20 gigabytes to go before I run into the swap. So if you're a video editor, up to 4K footage, if you're a photographer, if you're starting a small business, if you work from home in the Microsoft Office suite, not only do you not need an M5 Pro, but it literally would not function any different for you than the base model M5. Now, if you're compiling large code, if you're creating electronic music with 200 tracks and they all have effects on them, if you're really into Claudebot, OpenClaw, or you just want to experiment with local LLMs, if you want to run multiple virtual machines in the background at all times, if you're shooting and editing 8K video, or if you're just really into video games, then you've got the perfect justification to plunk down the extra cash on the upgraded chip. But you might as well upgrade that RAM while you're at it. This machine, 18-core M5 Pro, 48 gigabytes of RAM, 1 terabyte SSD, cost me $2,799. And my only justification is to leave apps open and play video games on a plane. Please subscribe to my channel to make this worth it. We are like 3 weeks away from 100,000 where I will be melting this old Intel MacBook Air into a solid brick. I'm gonna go get on a plane now and go to New York City. Next up, I'm gonna be taking apart my M5 MacBook Air and modding it to see how close I can get it to run to this M5 base model MacBook Pro. I guess in another week or so, that video will pop up right here on this very screen. So you got that to look forward to. Goodbye. Oh, MacBook Pro. I used a little too much brake cleaner on that one. I might have burnt my microphone. We'll see. Check, check, check. Still seems to be working.